Hey, I'm Dan Spears in Coach Brian's class, guest speaker for the day. The problem we're doing is the limit as x goes to 0 of sine of x cubed minus x to the third, all over e to the power of x to the 9 minus 1. So to start, we'll look at the power series expansion for sine to the u, and we're going to substitute in x cubed as u here. So that's going to be the sum of minus 1 to the n of x cubed to the 2n plus 1 all over 2n plus 1 factorial. And then we're going to put the minus x cubed here, just to carry that through, all over the power series expansion of e to the x to the 9, and we're going to just substitute that in for u. So that's going to be x to the 9n over n factorial, all minus 1. So then we factor out the expression to get the first term as x cubed. The second term is going to be minus x to the 9 over 3 factorial. Next term is going to be minus plus x to the 15 over 5 factorial, and so on, minus x cubed. And that is all over first term of this expression, which is just going to be x to the 9 over 1 factorial minus x to the 15 over 2 factorial, and so on. It's minus 1. The first term's 1. And that's plus. So then we can cancel the x cubed here and the 1 here, just to get x to the 9 over 3 factorial over x to the 9 over 1 factorial, and so on. Click over here. So then we take the limit as n goes to 0. Is it 0? Of x to the 9 over 3 factorial plus x to the 15 over 2 factorial all over x to the 9 plus x to the 15 over 2 factorial, and so on. And then you can notice that the x to the 15s and all the terms thereafter will cancel, so that we just get the limit as x goes to 0 of x to the 9 over 3 factorial over x to the 9. And then when you plug in x is 0, that's going to come out as 1/6 over 1.
Isn't Dan doing a great job so far? Obviously, there have been a few mistakes so far, but hey, it's stressful being up on the light board. First thing I want to just quickly address, if you notice here, he's not putting any n equals 0 or to infinity or any bounds on his series. And one reason it would be nice to do that is to know what the first term is. So that way, if he had an n equals 0, it would be quite obvious that 1 was the first term, and he wouldn't have accidentally started with x to the 9th. Obviously, we have this negative sign that we've dropped throughout the problem, so there should be a negative x to the 9th here, and that will affect our answer. So the correct answer in the end is actually going to be negative 1/6. And the last thing that I kind of wanted to address, though Dan gets the right answer, you have to be careful with how you think about this limit. Because if you just plug 0 into the x values, you get 0 over 0. And that is an indeterminate form, and you don't know what's going on. Also, this step to this step isn't quite correct. What you can do is see that x to the 9th here, and you have an x to the 9th here, and you can multiply by 1, or divide both the top and the bottom by x to the 9th. Then you'd have 1 over 3 factorial plus x to the 6th over 2 factorial plus blah, 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 all of these having x values. Here, it would be 1 plus x to the 9th over 2 factorial. Another small mistake, instead of this being 15, it should be 18, plus blah, 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 all of these having x's. You can do that, and you'd still have your limit. Then when you plug in n equals 0, all of these terms would disappear, but they only disappear once you're evaluating the limit. So if you has this limit sign out here, there should still be all these other terms. Then you only have a 1 over 3 factorial and an over 1, and that is obviously 1/6 over 1. But remember, we missed this negative that we forgot to distribute, so that's what makes it a negative 1/6. Well, thank you, Dan, for your hard work, and let's let you conclude.
Which is equal to 1/6. And I think that's it.